All right. So here's a few things you might like. These guys decided to test how well you can scrape data off the internet, and this is translated from German. And I think I might have the Twitter thread. Yeah, so Kashmir Hill, who's been a speaker here a couple times, does a lot of privacy investigations and stuff. She does things like she installed a bunch of IoT devices and watched how much traffic is leaving from her home and things like that. And apparently she started this one showing how you can easily scrape images off public websites, which is certainly true. But now in these days of powerful host machines and easy to rent cloud servers, you can do a lot more than you used to. And so these guys downloaded 200,000 Instagram pictures by just scraping for common hashtags. And they got a bunch of pictures about, I think, their local politicians, German or something. And then they were able to build their own AI bot to filter the pictures and match people. And they found a bunch of pictures of important politicians doing things like in the background at rallies and stuff and at parties that they didn't really want associated with them. They found a lot of like embarrassing stuff. And the point is just to show how dangerous it is, that there are now public repositories of everybody everywhere, and Facebook links them all with your name if you don't really like it or not. And there's commercial products that the cops have and other people that will search by face. And so this is, when Google first invented Google Glass, they put out a video of somebody walking around and you see a face and up it pops, here's their name, here's their phone number, here's their criminal history, here's their credit rating, just everybody you walk by, like RoboCop, you know everything about them. And we're pretty much there to where it's very easy to build that. There are commercial services that do it. Probably pretty soon there will be an app that does it, unless they pass a law increasing privacy in America. In Europe, there's a bunch of laws against this stuff, which I don't think they're stopping this, but this is of course fundamentally from American service. And this is why European companies have huge legal problems using American services, because the privacy laws here are much more lax. And in particular, Europe, non-citizens have no privacy rights at all. Citizens have very little privacy rights, but non-citizens none at all. And that violates the local laws everywhere to expose your stuff. And yet you can't get anything done without using all the American services that are free, like Gmail and Google and Yahoo. And so they have sleazy exceptions in the law that are temporary to give them like the ability to use these services, which are not private enough. And so this is a current big battle. And it looks like the scandal that's going to drive it is this extremely fraught concept that the Russians hacked the elections through Facebook, which I think is all garbage. I don't like agreeing with Trump, but he's right sometimes. I think this is complete garbage. I think it's nothing more than propaganda they've always been doing, but it seems to have traction to motivate people to pass privacy laws. And that is a frustrating thing, but that seems to be how things always work. When laws actually pass, it's because of a scandal, which often makes no sense, but it's just anything that gets people excited is what motivates them to actually pass a law. So our laws are the accumulation of irrational responses to disasters. Anyway, so ICE and the Border Patrol have purchased phone location data. There are open repositories of vast amounts of phone data, and they're using it in some way to enforce immigration law. Now, this is Trump trying to close the borders, block immigrants, kick out all the foreigners, get rid of all the Muslims. He has a very racist agenda to get rid of everybody outside the country, and they're trying to do it with a variety of techniques, many of which have been blocked as illegal. And nobody knows exactly what they're doing with this data, but it's in the same spirit as that Instagram stuff. There's just a lot of data about everyone, easily available for all kinds of people to use. And when the government uses it, we actually do have some legal defense against that in America because of the Fourth Amendment. So this is the one thing that's often difficult for my students to understand in beginning classes is that private companies like Facebook and Google can just do anything. But the government can't do very much because of the Fourth Amendment. But the Fourth Amendment only applies to the government. Private companies just have to have you sign a terms of service, and then they can just do anything with your data at all, like put it in ads, sell it to other companies and everything. But when the government's doing it, they might be able to stop them. So we'll see. Anyway, this is quite surprising under Trump. Something the leftists in America have been wanting for a long time is that we would actually start caring about right-wing extremists. And now the FBI has considered right-wing extremists to be as dangerous as left-wing extremists, or as ISIS and such, which is, I think, a big step forward. We've had, ever since Trump got in, we've had a huge amount of anti-Semitism, anti-Muslim violence, racism, and it seems like they have open season because they have strong support from the president, but apparently there are still some branches of government that would like to protest the right-wing extremists as well as the left, and that's good to see. especially since it looks to me like we're going to have another 4 years of Trump's. The Democrats seem to be in total disarray. So it'd be nice if other forces will try to balance this extreme lurch to the right. So these web shell attacks are a big thrill, and I'm putting a lot more of them in my mobile and my web device hacking class this semester, web hacking. And this just shows you how it works. And the thing I think that's important here is this attack framework, which I haven't included in my classes yet because it is sort of daunting and baffling. But this sorts what hackers do into like hundreds of categories, and it helps you follow what they do. So this is what this particular group of attackers do. They put a web shell on. What you typically do is find some way to upload a file, which is very common somewhere in the profile pic. And very commonly, there is some way to upload a script file by accident. There's a way to sneak up a PHP file or something. So you can upload a file, and then you have the ability to execute some code on the server. And you often just take a open source or commercial PHP shell. Now, in my simple hacking projects, you just upload one line of PHP, but you can upload a file with 100 lines of PHP that gives you a whole bunch of features. And so they check out a web shell. There's a bunch of these, and now they can use that to execute some commands on the server. So they now compromise accounts, recon, scan using NBTstat, which is a common tool to find neighbors in a network neighbor. That's Microsoft's neighbor discovery technique. Then they move across to PSExec, which is usually what you do, a Microsoft tool that lets you execute code on another machine now that you have credentials. And then you install a DIL backdoor in the Exchange server to take over the email, and on you go. And here's the technical categorization of these attacks with these numbers. And that's what the attack framework is for, which I'm trying to figure out how to add to my classes because it is sort of makes you sick to look at. It's a spreadsheet with like 10 pages and 100 lines, and it looks far too complicated. But this is what people are moving to, is to categorize things with this. So this is a web shell, brute force, account discovery, network share discovery, and they all have these code numbers. And the idea is you can now trace the attack flow. They call the kill chain of all the things the bad guys do. And then you can talk about your defenses. My defense will stop these ones, but not those ones. And we should therefore add this defense to cause those ones. And so it is, the problem is hacking is just very complicated. It isn't like there's 3 techniques. There's like 100 techniques. And you really have to block as many as you can. And if you have it all categorized, then maybe you can begin to have security metrics. This is the holy grail of this business, is to actually have a measure of how secure you are. We don't have anything like that. But it'd be nice to say your security is currently 5. If you buy this product, your security will go up to 6, and that will save you this much money. We would love to have that. We're nowhere near that. You hire all the security people you can. They put on all the products they can figure out how to buy. They tune them up, and then you still get hacked. And so you don't really know that you saved any money at all. They say, well, you could have got hacked twice instead of getting hacked once, and that might be true, and it might not be true. And the corporate executives will say, look, I want to see return on investment. I spent $1 million on security. How many millions did I get back from that? They say, I have no idea. We still got hacked. So it's not good, but that's why this is an art and not a science. And I think the same thing's true of policing, right? You have a drug war, you hire more cops, then you still have a drug war. And you say, well, did those cops do any good or not? We really don't know. We have statistics about how many crimes, but they go up and down because of the economy and the weather and everything, and you really don't know. It's the same thing with education. We need more security people, so we teach more security classes in college, but it's not really clear that it helps or not. You just go by intuition in these areas of life that are not sciences. So Cisco has their own neighbor discovery tool, like Microsoft's NBT, and this is CDP, Cisco Discovery Protocol. And like most things in layer 2, it is very unsafe. And that Dan Kaminsky, one of the most famous guys in security, has said layer 2 is not defensible. I did a bunch of layer 2 attacks years ago and took them at DEF CON and everything. Dan Kaminsky said, oh, layer 2 attacks aren't even worth talking about much, because once people get near your devices on the same local network, it's game over. There's nothing you can do. And certainly there are a bunch of nasty things you can do, like ARP poisoning and DOS attacks and such, that are very hard to stop. And I was saying they should segment things at layer 2 more to protect you from that. And to some ways, I rented a cloud server at that time in the early days of cloud servers, and I ran a layer 2 scan, and I found that I was on the same subnet as 180 other customers. And I said, I could attack any of those customers with these layer 2 attacks. And that's because at that time, people just ignored this. And if you rented a server, they would just stick you in a rack and put all the people in that rack in the same switch. You're all just sharing the same subnet, and they figured it the same local net. And they thought that was fine. And I'm saying that is really not fine. And anyway, I'm not sure about the server side, but on the client side, this has been improving. For example, if you go to City College now, or Starbucks, or Phil's, and connect to the network and scan, you're the only one on the network. It has isolation mode turned on the router. Every customer is on their own separate network. So you cannot do these layer 2 attacks against other people. So at least on the client side, people begun to realize this is unsanitary and not wise. And by the way, it fouls up some of my projects. If you try to have two virtual machines talk to each other, if they're in bridge mode and you're at Starbucks, it won't work, or at City College, because they'll be isolated. And so in most cases, that improves your security, and that's good. Anyway, so that's probably enough news to get us started. So we have, this is CNIT 50, which is just a 1-unit class intended to be easy. And so let me just talk about where we are. This class only meets a few times through the whole semester. So this is just the second meeting. Here's the first meeting. If you missed the first meeting, there are videos here. And the most important thing you need to do is enroll in the Splunk online course, which is a free course with videos and little quizzes. And you do that down here. I had somebody calling me yesterday about how to do it. So here at the top of the lectures, this is how you enroll. You should enroll in this course. You kind of have to follow these instructions because the Splunk page is sort of confusing. It's easy to fall off the track and get lost, but it's a free thing. You sign up for this course and then you have some time period, 30 or 60 days, free access to all that stuff. If you somehow can't do that, I have archived the materials and you can put you in there with the name and password that I put on the board there, but I don't recommend it because Splunk says I shouldn't distribute them and you really should just get your own. But if for some reason you can't, or your 30 days expires or something, I have archived the materials there and you can get at them if you like with that name and password. I just don't make them available to the whole world because Splunk says not for distribution, so I don't want to irritate them too much. So, anyway, that is an option if somehow you can't get to the real online class, but it's much better to get to the real live online class. And if you have trouble, after the lecture, I'll go down to Science 37 where there's computers you can use and I can help anybody do it or any of the projects. So I took the PowerPoint from Splunk and I imported them, turned them into Keynote so I can just have slides to display. So this is my plan. And they have a hands-on project where you are searching for customer data in a Buttercup Games database. But I'm going to just use my cloud server to demonstrate these things. So this is, let's make this bigger. All right. So this is the, let me just go through the steps to get here. If you go to samsclass.info here, there's the modules here, which you should turn in, which are practicing the Buttercup Games thing that the Splunk Online course tells you to do. And I just have you turn in like a screenshot towards the end to show that you did it. And you're emailing them in. So these all come in. When you're done, you get a screen image and you send it to this address, cnet50sam@gmail. So that's how you turn in your homework. And then after you're done with that, I highly recommend Boss of the SOC. Boss of the SOC is beyond the Splunk certification and the Splunk online course, which is really very rudimentary and simple, but it's much more fun because you're actually finding real threats. So I put up a couple public servers which you can practice on, Splunk 1 and Splunk 2. And they don't open correctly in Brave, which for some reason can't handle HTTP basic authentication very well. I'm using HTTP basic, which is a really old, almost obsolete protocol. So it's not too surprising that modern browsers can't support it, but it was just the simplest way to secure my server so the whole world isn't just flooding it with junk. Anyway, so I just switched to Opera. Most browsers can handle it. So here's what you have. This gives you 1 million events to search. And I'll demonstrate with this. And if you type a few letters, it helps you search by suggesting things. And what I want is index bots v1. And I don't need these other terms right now. That's just a search I did recently. Okay. And so now I'm finding the last 24 hours of events in this index, and there aren't any because all these are from 3 years ago when they made this stuff. So to see them all, I'm going to switch to 1 for 1,000 event sampling to make the search faster and switch to all time. And now it's going to show me 900 events. There's really 900,000 events. And so these are events seen. And so I'll just use this to demonstrate some of the basic features of Splunk and here's the Splunk slides, which are really very simple. You know, we just want to have a live Splunk to look at. If you are following these steps, you will have installed your own Splunk and downloaded some Buttercup Games demos data, and you can practice with that, or you can practice with Boss of the SOC. Anyway, so, all right. So here's where we are. Basic search. This is the main thing you do in Splunk is spend all your time searching to find stuff. The search assistant is what I was just showing. If you just start typing things, it will suggest how to finish it. You type a few letters, it'll suggest options. So it helps you. This is true of almost all modern command line interfaces on a Cisco router, in PowerShell, every place you go, they try to help you this way because the #1 problem with command line is people spell things wrong. So they try to make it so that you don't really have to remember more than a couple letters. And so that's the search assistant. It can just help you. You can click on one of these suggestions, or you can just keep typing. All right. You can, by the way, set the specifications of the help assistant if you want to different levels of verbosity, but I find the default is fine. All right. And so in full mode, it gives you more options, and you can turn up to various levels of help. But like I said, default is fine. The default will also help you if you have parentheses. When you click a parentheses, it will highlight the previous one that matches it. This helps you deal with unmatched parentheses. And this is quite common in text editors, code editors, and everything these days, because that's another one of the huge problems with command lines is matching your parentheses. Usually I don't make searches that are this complicated that you need very many parentheses, but anyway, in principle, you can have long, complicated searches with nested parentheses and all that, and it will help you with them. So when you enter things, like you see, as soon as you click search on the right, it'll show you the results. The results show up down here in reverse time order, the most recent events first. There are 3 ways to see results. This is a list, which is not often, this is the one that has these colored breakouts. So this event, which is some kind of network traffic, has got a destination IP and an event type flow and so on. This event is much simpler. This is a Windows registry event and so on. The events are presented in some view like this. This one is expanded to show you all these color-coded fields. You can click this to expand this one, and it will then show you a chart of all the details of this event. So this is one view. Another view is, there's 3 views. If you go to raw, you'll just see the raw data that Splunk indexed. And this is just a raw text event log from some log. And remember, everything is in here: Apache logs, firewall logs, web server logs, every kind of Microsoft Windows event logs. Each product makes a log, and this is the raw data. So if you really wanted to just grep through the raw logs, this is where you'd see it that way. Of course, the whole point of Splunk is to try to get beyond that. Before there was Splunk, we would just grep through logs, and that was such a drag, they invented Splunk. So, but you can see the raw log data here if that's what you want. Mostly people, you like the list view is the best. Table gives you columns, so it goes all the way over to the right, a mile across. This is kind of weird. I can't imagine much use for this unless there's just one column you really love and you want to focus in on this one column. So that's right, most of the time you just leave this thing in list. And that's the most friendly event. If you collapse them, you get a summary. If you expand it, you get this list of all the fields and values. And that's sometimes colorized and it sometimes isn't, depending on the event. But that's often the most helpful thing. Typically, just like Wireshark, looking at events here one by one is for the birds. The whole point reason you're using Splunk is you have a lot of events, like 1 million. Just like when you use Wireshark, you catch 10,000 packets. You can look at them one by one, but you'd have to be out of your mind. Using the summary features like over here is far more helpful. So you choose a field like action, and now there's only 6 possible values of that. Now this is helping. So you say, I want the allowed ones, I want the blocked ones, that kind of thing. This is the way you get places in all databases. All this is a database, just like SQL, just like Access. And the way you get places in database is just by categorizing. I want all the data. I want all the data with confirmed purchases. I want all the data with purchases over $1,000. I want all the data with bounce checks or something. You categorize them to cut into pieces until you zero in on what's interesting. That's how you have to think. Otherwise, you will just waste all your time going one by one through a giant pile of junk and not finding the good stuff efficiently. All right. So Splunk sorts them into events. It assigns metadata. It always gives you a timestamp, a host, which is almost always useless. That's just the name of what server produced the data. Source and source type are very useful. We've used that before. We were talking about this. Oops, that's not what I wanted. Let me clear that. Do I need to clear it? I guess I'll go. I accidentally zeroed out a 1 time zone. I'm going to hit all time and see if that clears it. It does. All right. So the source is down here, source and source type. And there it is. They're often the same. And those are very helpful. That helps you say what it is. This is a Windows event log. This is a IP stream. This is a FortiGate firewall log. And this is an IIS web server. That's often very helpful, because often there's one of those you want. And looking at the source type will tell you, because Splunk has everything just in a big pile, and you often do only care about a certain type of data. Like I only want the firewall logs, I'm looking for blocked events, or the Suricata logs. I'm looking for events that were detected as malicious, that kind of thing. All right. So you've got search result number appears here, the check mark appears here when the search finishes. You've got this time bar. You can pick time ranges if you want to. You can pick general time ranges up here. And you go, every event always has a timestamp. Splunk finds time essential, so it always puts a time on every event. So it can sort by time. And then you can choose what fields to select. It'll choose a few fields like source and source type and put them up here as selected. Then it has interesting fields, which are just any field that appears in more than 20% of the data. And then you can go to the bottom and see more fields. And those are the fields that are in less than 20% of the data. So normally you don't care, but you might need those. And you can choose one of these fields. Like if I decide I really care about app, I can elevate it up to this side. If I hit app, I can then say selected yes. And that'll move it up here just to make it easier for me to find. Or if I'm tired of all this junk being selected, I can get rid of it with no. And it's still there, it's just moved down here. So you try to keep this list kind of short to what you really care about, but you can always go down there to find other things. All right, so if you highlight over a word, it'll offer you things. So I like to go down here to filter my search, but you could also go here if you had a complicated search like Batman. If I search for Batman, find a bunch of events called Batman, and if I search for, say, get, I'll get request word to contain the word get. So now if I wanted to highlight, do some more, I could point to this term, and I ought to highlight it. Let's see, not working too well. Maybe I'm not gonna be able to demonstrate this live. Oh, down here, okay. So if I go down here and I highlight one of these, yeah, it's not working very well for me. Maybe I have to collapse it. Let me see. All right. Maybe I'm not going to be able to find a good demonstration of this. It works under some conditions, and all right, I'm not having any luck finding it. But sometimes you can highlight things down here and add them to a search there, which amounts to the same thing as finding it in the left column. I've done it a few times by accident. I don't know why I'm not succeeding in doing it now. Maybe I have to expand it. Nope. Maybe go to the other view or something. Anyway, I don't feel like struggling with it. It happens to be sometimes when I don't care. So that's the point. You have, and we talked about these layouts. You've got various ways to view it. You can put it in number per page, raw, list, and table, and so on. All right. And we talked about the time range. For our purposes, we're always going to use all time. But in the real server, they always tell you don't use all time because you have way too much data. You should always limit the time. That is your most important thing to avoid having too much data, is to limit the time to the time zone of interest. Anyway, and you can use the time range picker to pick things like last week, last hour, or you can actually specify it with a search with seconds, minutes, hours, days, and all that. And you can use an at, which will go to the beginning of the hour or the beginning of the day. These are just ways to express it in the, if you like typing a long command line search instead of using the mouse to pick it off a list. So the earliest equals this time, earliest is -2 days back to the start of the day, latest is today at the start of today. That's one way to express time ranges. You can also pick them off this bar. The bar shows you the number of events, and you can click and drag to pick some of the events. So I should be able to demonstrate that. Yeah, here we are. I only got 4 events here. So I could change my filter. I think I'll just change my sampling. I'm only doing 1 in 1,000. So let's go to 1 in 10. And that will give me more events. Now I got 395 events, and I can see them at various times. So I could get the ones from this time to that time. And now I've only got 154 events. So you can zero in on time this way, or you can go here. And by the way, you can specify exact time ranges here by date and time. And for some of the advanced ones in BOSSOSOC, you will have to do that. There's a couple of them where you're looking for events without an obvious keyword, and you really have to narrow your search down to like just a few seconds at the right time. And I'll just mention this thing, most frustrates students on that one is the problem of the time zone. I think this stuff was collected in mountain time. But anyway, you will often find that you're off by an hour and you're trying to zero in this time range and you can't find it. So watch out for that. And that is a huge problem. This, by the way, is a technical term for this stuff is network forensics. And that is a problem with all forensics is time zones. Make a huge problem for everything. You try to find out when something happened and you have multiple sources of data and they're not really in the same time zone. And you have to constantly watch out for that and be careful about that. You can make awful mistakes because some of your data is not when you think it is. So I've definitely heard of cases where they're actually throwing the wrong person in prison for that. There was a teacher, a Japanese teacher in a high school. They accused him of viewing pornography in the high school because they had the wrong time zone. It was a substitute teacher at a different time. And they went all the way of him getting his wife left him. They threw him out of his church. He was published as a pedophile, driven out of the industry, all because it was wrong. It was totally not him, but an incompetent examiner didn't check the time zone and accused the wrong person. Anyway, this kind of thing does happen a lot. Anyway, hopefully we won't be working in situations with that much high stakes. Most of us, we're just trying to stop attacks and we're not really going to be throwing somebody in prison, but some people really working at the military and law enforcement, and it really, really matters not to blame the wrong person. You might send a drone over to kill them and then say, oops, that was the wrong guy, sorry. And that stuff totally happens, but you clearly want to avoid that. Anyway, so we talked about the time zone. There's a lot more details of time zone selection. These things are, by the way, jobs. If you have a real situation with all the data, you can start a job and it might take 5 or 10 minutes or longer, and then you get really frustrated. So you can watch the jobs over here. Each search is a job on the database engine, and you can see them here. You can inspect the jobs, you can delete jobs. By default, you own your jobs and nobody else can mess with your jobs. You can even share a job if you want to send it to other people and say, look at this and look at this search, and then they don't have to rerun the same search, which might have taken a long time. They can just look at the results. You know, those are good things in a real enterprise environment where jobs are big and you're wasting a lot of time on them. And of course, in our little test environments, it doesn't matter that much. But you do have those options to control the search jobs. All right. And by the way, I think the lifetime is 10 minutes by default, and it can be extended to 7 days. Otherwise, it throws them away. Obviously, you don't want to fill up your cache with all this stored searches that most people don't care about. It does, by the way, have a side effect. If you just start typing in things, you'll find what other students have typed in on my server, and you can totally like cheat on things that way. That's a thing to know, because you're all sharing the same user account on these servers. That's one of the many sloppy things about my projects. You know, really, my projects are pretty easy to cheat on. So, you know, it's just, you're an opportunity to learn. If you want to actually do the work and learn, if you totally want to cheat, that's pretty easy too, but I don't recommend it in this class. In my, one of my classes, there's a project where you totally have to cheat, and that's by design. But anyway, this stuff, I think you should actually do the Splunk work as best you can if you want to learn your Splunk. Anyway, so that's to talk about sharing your search jobs and exporting. You can put out your data in XML or CSV to send just the data to somebody. That's another way. And that's the only way to preserve it for a long time. Otherwise, you can only save it for 7 or 10 days. If you really want to keep it forever, you should export it to some kind of file. And you can see your jobs and so on. You can look at your search history and see what other people have been doing if you're all sharing the same account like we are, but normally you have your own user account, so you only see your own search history. And this is fairly common, that you're searching for things and you search for things and you say, well, I really want to look at the thing I found half an hour ago. So just like your browser history, your search history can help you keep track of things. All right, and so fields are, now you can search just like I did with Google, where you just put in words like Batman and get. Splunk hates this. This slows down the search because this is just like grep. All this does is take the raw data. Come on, here, and just look through this for a match, Batman and get and so on. So that is the simplest kind of search, and it's the slowest kind of search. It would be far better to, instead of just putting get there, to go to HTTP method here and do this. And now, instead of just get, you have HTTP method equals get. That is far better. You look for this one field to have that one value. That will be faster and more precise. If I just put get, I'm going to see like a web page that has the word forget in it, which is not really what I wanted, but it technically matched. So, you know, this kind of search is kind of for amateurs. This is what the Splunk people really want you to do. That is better. That is more precise and more professional. I mix them both because I just care about getting results. But, you know, this is the kind they mostly want you to do. Name equals value. And if you do that, then you have things like status equals 503, action equals purchase, and stuff like that. All right. Splunk will automatically parse the data into fields. We talked about that last time. When you import the data, you specify what type of data it is, and sometimes you even have to write a parser, and it picks out the fields it can find. And so everything has to have source, type, host, date, and often you'll have other things. So you'll have action equals purchase. Now you've got a pile of data. Some data will have action, some data will not have action. And so often you're searching for things that are not always there, like status will be there in an HTTP request, but it won't be there in a TCP request, and so on. So, all right. What I often mainly work through down here, I go to the field sidebar, find an interesting thing. So when I'm searching for something, I don't know what I'm doing, I go down here and I look for, this thing has like 100 or more different values. That's kind of useless. I look for something with a reasonable number of values, like this, 14 possible values. Well, then I might possibly be able to narrow the search with that. Find something that looks kind of meaningful and has a reasonable number of choices. Like here's comment. Yeah, 200 okay, 500 not found. This might help me. I might want the ones that worked. I might want the ones that didn't work. That's what you do. You search down here for things that will help you zero in on the interesting data. All right. And we talked about that. You can make these selected fields by just clicking select on them. And all that does is move them to the top of the list. It's just a cosmetic change. All right. And we talked about this. So in the fields window, once you select a field, you can then have average, maximum, top, rare values, events with this field. Like only 100% of events have this field, but there are others that they won't, like user agent. Clearly only the HTTP would have that. That's 99% of the events, because I already specified method equals get. So it's kind of hard to understand how this would not be an HTTP method. Apparently there are 3% of events that somehow have an HTTP method field without that other field. Anyway, that's because we're just getting events from all over the place. All right, so like I say, fields are quite useful. You could just search for an IP address, and then if you're looking for that string, it would be more precise to have client IP equals that, and so on. But, and like I say, status equals 404 is quite different than area code equals 404. But if you just type 404, you're going to get both of them in a pile. And all those can be useful depending on what you're doing. You just should understand what it means. It's the same thing it means at Google. You just type in 404, it will find anything that has 404 in it. And that I do in the beginning when I don't know what I'm doing at all. All I have is one keyword, so I don't care. I want a web page, an email, anything with that word in it. And then after I look at a few, I say, well, what I really want is the email or something, and on you go. All right. So by the way, Splunk understands IP addresses, so you can put in /24 or .* and all that, because you know they're trying to make it helpful. You can use star. This will show every events, everything that has that event, any value in it. If there's no such thing called user at all, it won't show up. You can do greater and less than. You can use not equal, and on it goes. All right. By the way, not will exclude things that have that. Not equal will require the field to exist and have a different value. So there's a subtle difference. Events that do not have a status field at all will appear if you do not status equal something, but not if you do status not equal something. So that's one of those little gotchas. All right. So here's status not equal, gives you 3,000 events, but not status equal 200 gives you 66,000 events, because there's a ton of events that just don't have a status field at all. So these are not the same. All right. And of course, sometimes they'll be the same. If you have an event that's always, if all the events have that field, then there's no difference. All right. And there's different modes, fast, smart, and verbose with details. Smart is the default, which is what I almost always use. You can try these other modes if you want to. In the Laws of the SOC, they said you should be using verbose mode, so I tried switching to it, and I didn't find any merit in it. I just went back. So anyway, so that's the online lecture stuff. Like I say, it's all ridiculously easy. And now I just want to talk about a little more about Boss to SOC. Like I say, first do the online course, make sure you've done that. Then you can get your certification, and that's good on your resume. Everybody loves Splunk. They'll hire you to run Splunk. But if you want to have a good time, I highly recommend this Boss of the SOC. So I just want to talk a bit more about this. So you start with index equal bots v1, like I've done here. And then if you want to see events for their web page, the web page for this thing is I'm really not Batman. And you could type that out, I'm just putting in Batman. If you find events that contain the word Batman, Right now, I'm only seeing 10% of them, which is all right. I might even make this, yeah, okay, it only took that long. That's not bad. So I have 714 events that contain the word Batman. Now, if I look at them one by one here, I probably don't want to look at them in raw mode. Let me make my window bigger. And let's change this from raw to list. All right, and I feel like this response is pretty slow. I'm going to change this to 1 to 100. There, now I'm going to be looking at a smaller number of events. And all right, so now I'm seeing these filters. So this event looks like, this is what I recognize as an HTTP Splunk stream event. Splunk stream sniffs the network and creates network data. And by the way, I just checked today, you can in fact configure it to keep whole packets like Wireshark. There are different modes, but it also looks at net flow and other things. It somehow watches the raw network. And that's why you see the whole web page, HTML web page. If some web request fetch the web page, and you'll see the whole web page here, and you'll see all the headers. This is the 200 header and the expires and the cookies and everything. And then you'll see the source request here. And so on it goes. So this particular one sent a cookie and then came from another place, Joomla administrator index. This looks like somebody was logged in as the administrator and they did something to Joomla, and this looks like a perfectly normal HTTP request. This does not look like malicious activity to me, not obviously. It doesn't have an indication that came from a vulnerability scanner. This is somebody doing a request, and that request was, I think, successful. Yep, it got a web page, and the headers will show me a 200 OK. So they requested some page and saw it. So this is pretty boring, although there's probably something wrong with it. It's more subtle. Anyway, that's kind of a big event. There's more events, and there will eventually be different types of events. So now that I've looked at one event, I'll go down here and see, here's here's something I might care about, source IP, where it came from. So 52 events came from that person and only 7 came from that person. So that's interesting information. Here's the URL. These people are doing searches. This person's doing something on the administrator page. This looks like so trying to send an email message. This is looking sort of suspicious. That looks like some kind of attempt to do an attack with all these weird characters. That's testing for cross-site scripting or something. So that's pretty suspicious. And also these things were only done once. So this looks like the vuln scanner. So if I pick one of these, it will add it to the search, which makes the search bar kind of ridiculous looking. But anyway, now notice I have no events. This is what you get for using sampling. Sampling is random. I was only looking at 1% of them. I found one event, but the next search didn't happen to pick up that event in the 1%. So if you're going to be this narrow, you got to quit sampling. There must be at least one of them, and there is one of them. So now I found just one event. I think, although it's not done, yeah, it is done, check mark. Now here's my glorious one event. And this one event, if I go down here, those are the destination headers. I want the source headers. There they are. Here you can see this is the vuln scanner, which is what I figured. That stuff looked ridiculously obvious as an attack, and that's what you get from a vuln scanner. So this is the Accunetric scanner. So this one event, which you can find, this event in a lot of ways, will answer like the first 4 flags. Because the first 4 flags you're trying to find here, by the way, I just added this today. This is how you turn in your project. Take a screenshot with the flag highlighted and email it in. That's how you get points for these things. And there's a whole bunch of little things to look for here. So the first several you can find just by finding one of those vuln scanner events. So the name of this vuln scanner I found, the IP address of the attacker, and the IP address of the web server are of course here. So I look at this event. Here's the name of the vuln scanner. It's just right there because commercial vulnerability scanners mark all the traffic. And the source IP is the attacker, and the destination IP is the web server. So it's all right here. So now I know several useful things. I know the IP address of the attacker. I know the IP address of the web server. And now, oops, I want to get back to this one. All right. Now I'd like to find the file used to deface it. And I think we did this last time. And for this, we just want to look at the events that go backwards. So I know the name of the web server's IP address is this, 192.168.250.70. So to find the traffic that goes backwards, I want to get rid of all this. And I'm going to get rid of all that. I'm going to go back to sampling for a minute. Start with all the data. And then I'm going to go to source type. And I want stream HTTP. So I'm not seeing it in my list. So I'm going to do SMB and just change that to HTTP. So now I'm getting web traffic. Now I would like to find the source IP of the web traffic, and I'd like to restrict that to the IP address of the web server. So I'll pick anything here just to avoid typing, so I don't make typos. And now I put it in a clipboard before the IP address. So I get rid of that and put in the right IP address. So now I'm getting HTTP requests that came from the web server, which should not be allowed. Your web server should be a server and not a client. And if you're allowing your web server to open a browser and go somewhere, you're doing it wrong. And that's what happened in this case. So now I find 0 events, because what's wrong? Sampling, right? I'm only looking at 1% of them. Now I better turn off the sampling. And now I will find 8 or 9 events. It's still going because I don't have the check mark yet. Looks like now it found 8 of them. By the way, if you use like client IP, you'll find 9. If you use source IP, you'll find 8. Both are fine for our purposes. These are the events that went backwards. And so if I look at these events, here it is going to this, here's the host name of this thing, this ridiculous name. That's the going on port 1337. These are really clear, obvious script kiddie stuff. 1337 is the classic number hackers use. Stupid names like that are what hackers use. So now I have the name of the file they downloaded, and I have the domain name of the server, and those are a couple more flags. So that gets, you want the domain name and the stage. Now I know the staging server's IP. This request went to their server to download a malicious file. So the destination IP here is the criminal's staging server, which is probably another victim. That's why when people do hacking back, it's bad, because the person that is the source of your attack is probably not a criminal, it's probably just another victim. But that's the direct source of something bad coming into our network. Just like the scanner came from an IP, and you could attack them, but you probably wouldn't really be hurting the bad guys. Anyway, so there's the IP address of their staging server from which they're downloading the file. And now if you want to find other domains on that server, this is very common. So that server is apparently being used by criminals to host malicious files. So it's probably being used for that purpose for a lot of campaigns and a lot of attacks. And so before long, they will get busted by other people using intrusion detection systems, and they'll be in a public database. So you just go to Google, and there are several well-known public databases. Typically, if you just put in the IP address of a known malicious server and just search for the IP address, that's what you'll find. And here's common ones: Threat Crowd, Alien Vault, Threat Miner. These are open source intelligence services, which is huge these days, learning how shared information between people. And so if you just open a couple of these, you'll find more information about that server. And of course, each one of these evil servers typically has a bunch of domain names that point to it that they use in spam or malicious pages, and they keep having different domain names go back to the same server. So here's a whole list of domain names that were used. Wayne Corp, Inc. It's actually an Amazon server. Most things are hosted on cloud servers that you rent or compromise, and then after a while you get busted and you just make another. And so some ones down here that are in leet speak, and those are the ones you need. Here's the one that was actually used, this prank glassine bracket jumping crab is one of the many domains going there. So this particular attack used that domain name. Other attacks would use these different domain names, but they're really all going to the same server, which is very common. And there are many different open source intelligence services that do similar things. And as you mature in the business, you get used to your favorites and how to use the advanced features and stuff as you learn how to look up stuff about bad guys. And if you go down south, which I highly recommend, to Sunnyvale, and go to the Pacific Hackers monthly meetup, which I go to, the guy that runs that is really into the stuff. He makes CTFs and he has a lot of open source intelligence. Find this, find that. I remember the last one I did, he wanted Jeffrey Epstein, the pedophile who died, had a notebook of all the people that had been at his parties he was fixing up with underage women. And that is presumably why he was killed. And that notebook has leaked online. And one of the flags in the CTF was to find that notebook, which I couldn't find. But if you're good at open source intelligence and you know how to use the torrents and the dark web, this stuff is out there. And it's not just a grubby, prurient desire to see rotten stuff. If you're in the business, you want to know what the criminals are doing. And you have to sort of get used to how to find these underground things. I have a little, like when the Iowa got hacked, I was able to get that app the next day from underground contacts. You need underground contacts. Then if somebody posted it publicly a day or two later, so now we can all have it, but they're taking a legal risk. I wasn't willing to take that legal risk, so I got it through underground channels and sort of concealed that I had it for a while. Because you do have to have some ability to get stuff that is not public information. Anyway, I think that's probably enough of this. So I'm just planning to stop. I'll stop the recording and I'll leave the network share on for a little bit. And if you want to work here and get help,